Problem 20. Find a so that f of x is continuous on the entire line. And our function is the piecewise function, x plus 3 when x is less than or equal to negative 1, and 2x minus a when x is greater than negative 1. Let's look at the definition of continuous again. The first condition of being continuous is that f of c is defined. And I noticed just by looking at the problem that at negative 1 something's going on because that's where the graph is being separated. So I need to make sure that f of negative 1 is defined. And if I look at that, I do notice that there's an equal sign on this part of the problem, which means the point does exist. So condition 1 is met. Okay, condition 2 is that the limit as x approaches negative 1 exists. So this is the one we're going to concentrate on. In order for the limit to exist, the limit from the left must equal the limit from the right. So we know that the limit as x approaches negative 1 from the left has to equal the limit as x approaches negative 1 from the right. So as we're approaching negative 1 from the left, that would be all the values that are less than negative 1. So I'm going to plug negative 1 up into the top function. And when I do that, I'll get negative 1 plus 3, which would give me 2. Now if I find the limit as x approaches negative 1 from the right, that would be from where all of the values are greater than negative 1. So I'm going to plug in negative 1 into my second function. So I'll get 2 times negative 1 minus a, and that will give me negative 2 minus a. In order for the limit to exist, I know that those two answers have to equal each other. So now solving for a, I'll add 2 to both sides. So I'll get 4 equals negative a, and then just multiplying both sides by negative 1, I end up getting a is equal to negative 4.